Morning, afternoon, evening, forever you're watching. You're welcome back once again to the Making Masters, a channel solely dedicated to demystifying mathematics, making complex problems look easy. Alright, what do we have today? Inverse variation, a request from one of the viewers from the channel. I think Adewumi, if I'm not mistaken. Okay, shout out to you. Alright, this is a continuation of the series under variation. In the last class, we looked at direct variation, and what we established in direct variation is that when two quantities, talking about two quantities, when there is an increase in one, it causes an increase in the other one. But for inverse variation, when there is an increase in one, there is a decrease in the other. When one goes up, the other comes down. When one goes down, the other one goes up. That's inverse variation. Let me give you a practical live example. For example, if I'm having a large field or a farm to harvest the crops in there or that were planted in the farm. Now, if I employ, let's say 50 workers, the time it will take 50 workers to harvest whatever crop is there, it will be more, or they will take less time than if they were like say 20 workers. So the more workers I employ, the less the time it takes to harvest whatever crop is in the field. But the less the workers, the more time it takes. If I say so worker, maybe 20 workers working at the same time, clear this field, and I say maybe it takes them 5 days to clear the field. If I increase the number of workers and they are working at the same time, the number of time they will use to clear the field will be less. On the other hand, you can also have another example, a real life example. For example, I'm going somewhere and I'm driving. If I increase my speed, the speed of the car at which I'm driving, I will arrive at the place less time than when I reduce my speed. So for example, if I say I'm moving like 60 kilometers per hour and the journey is for 1 hour, the same duration, if I increase the speed, I will get there in less time. But if I reduce the speed and drive it slowly, it will take more time to get or arrive at my destination. So that's inverse variation. In summary, when one goes up, the other comes down. When one comes down, the other goes up. Let's look at an example. This one, if y varies inversely as x, and y is 10, when x is 3. Remember what I said in the earlier class of direct variation? You can check out the content on direct variation. Now, the first set of values are used to find the constant of proportionality. So we are told that y varies inversely. So solution, y varies inversely. The inverse, you put 1 over x. This is how to represent inverse variation. 1 over x. And it says, and y is 10. So to remove the proportionality sign, we introduce the constant of proportionality, which is y is equals to k times 1 over x. So here we have that y is equals to k over x. So this is like the formula for inverse variation. Okay, so the first thing we are given, y is 10, x is 3. So we use y is 10, x is 3. We use it to find our constant. So whenever we see y, we put 10. So this is 10 equals k over 3. Here we cross multiply. So our k will be equals to 10 times 3, which is 30. So it says find the equation connecting y and x. The equation connecting y and x, like we mentioned under direct variation, after you have solved for the constant, impute the value of the constant, and that's all. So the equation connecting y and x is so y equals to 30 over x. So we have the b part. It says find the value of y when x equals to 5. So we use that formula, y is equals to, that's 30 over x, and our x is 5 there over 5. So our y will be equals to 5 here 1, 5 in 30, that's 6. So our y equals to 6. So when x is 5, y is equals to 6. All right, let's look at the second example. It says the electric resistance R in ohms of a wire of a given length varies inversely to the square of the diameter of the wire, that's D in millimeter. If R is 27 ohms when D is 5 millimeter, find the formula connecting them. Okay, let's look at the first one. The formula connecting them. The first line says R, the resistance R is inversely, varies inversely. Inversely, that's 1 over to the square of the diameter D. This is square of the diameter D. So we have brought out the first expression of the first statement. Now let's look at what we are given. Let's remove the proportionality sign by introducing our constant K. So our R will be equals to K over D squared. Now let's find what the value of K is. If R is 27, so whenever we see R, we put 27 equals to K over our D. Where is our D? 5 millimeter. So that's 5K over 5 squared, because it says D squared. 5 squared is 25. So our 27 will be equals to K over 25. 5 squared is 25. 5 times 5. So cross multiply. So our K will be equals to 27 times 25, which will give us 675. 27 times 25 will give us 675. Now the formula connecting them, you put in the value of the constant into this equation. So the formula connecting them is R is equals to 675 over D squared. So this is the formula connecting the two of them. R is equals to 675 over D squared. All right, let's look at the B part. It says find the value of D when R is 12 ohms. So from here, our R is 12 ohms. So we impute wherever we see R, we put 12. That's 12 equals to, we already found out the value of our constant, which is 675. So that's 675 over D squared. We are looking for the diameter D. So you can cross multiply. So our D squared will be equals to 675 over 12. All right, we can use 3 to divide. 3 here will give us 225. 3 here will give us 4. Now, we are not interested in the value of D squared. We are interested in D. To remove your square, you introduce your square root. Take the square root of both sides. So this is D squared. Square root of 225 over 4. This square will cancel this square root. So our D will be equals to square root of 225. What number will I multiply 2 times to give me 225? That's 15. 15 over square root of 4. What number will I multiply 2 times? That will give me 4. That's 2. So our D is equals to, you can break this down. This is 7.5 or 7.5 if you have to put it in decimal millimeter. So that's the value of our D when our R is 12 ohms. All right, let's look at this third example. It says X is inversely proportional to the square root of Y. Our X is inversely proportional to the square root of Y. That's X is inversely proportional to square root of Y. Then we are asked to find the constant of proportionality if X, that's our K. So from here, that means our X is equals to K over root Y. Okay, so find the constant of, find this K. If X is 9, so wherever we see X, we put 9. 9 equals to K over, what's our Y? 16. So root 16. So square root of 16 is, what number will I multiply 2 times? That will give me 16, which is 4. So that's 9 is equals to K over 4. To get our k, multiply both sides by 4 or cross multiply. So our k is equals to 9 times 4, which is 36. So our k, our constant of proportionality, is 36. All right, let's look at the B part. Says find the equation connecting x and y, just like we have been doing. The equation connecting x and y, replace the formula or the value you got for the constant, and that's all. So the formula connecting them is x is equals to our k is 36 over root y. And the last part from here, find the value of y when x is 25. So let's make y the subject of the formula here. So we have that our x is equals to 36 over root y. Then from here, cross multiply. So we have our x root y is equals to 36. Divide both sides by x. So our x, or sorry, our root y, because x here will cancel out. Root y is equals to 36 over x. Now, for us to find out the value of y, take the square of both sides. Square of both sides. This and this will cancel. So our y is equals to the square of 36 over x. Now, they said when x is 25. So when x is 25, wherever you see x, you put 25. This is 36 over 25, all squared. Now for us to do, let's divide this. 36 over 25 will give us, that's 1.4. Yes, 1.44. So our y will be equals to 1.44 all squared. And when you square this will give us 2.0736. 2.0736. All right, I hope you have enjoyed today's class where we learned inverse variation. And the most important thing, when one quantity increases, the other decreases, and when one decreases, the other increases. Just like in our usual style, before we go, here's some list of take-home fun that you can practice at your leisure time. The first one says p varies inversely as q raised to the power of 3 and p is equals to 8 when q is equals to 2.5. Find the relationship between p and q. That's the first question. B says find the value of q when p is equals to 216. The second question says if m varies inversely as n and m is equals to 4 over 3 when n is equals to 9, what is the value of m when n equals 8? And the last one, but not the least, the intensity I of a wave varies inversely as the square of the distance d from the source. If I is 250 when d is equals to 30, find the first one, I in terms of d, that's make I the subject of the formula. The second one, the value of I when d is 25. And the last one, the value of d when I is 10. All right, do let me know the answers in the comment section. If you enjoyed today's class, why not give us a thumbs up, give us a like, share the video, tell your friends about the Mickey Masters, a channel solely dedicated to demystifying mathematics, making complex problems look easy. And if you are yet to subscribe, kindly hit the subscribe button, turn on the notification bell so you'll be the first to be notified when new content on the channel drops. Till we meet again, keep practicing. Remember, mathematics is fun. And if there's any other aspect of mathematics or you are struggling with, just like Adewumi requested for this video, put it in the comment section and I'll be there to attend to it. Also, let me see the answers of the take-home fun in the comment section and I'll be there to answer to it. Shalom.